8A, evaluating expressions. So when we talk about evaluating expressions, we're talking about taking formulas, expressions, equations, and essentially substituting in numerical values in place of the variables. Okay, so when we first talked about algebraic expressions and equations, we mentioned that those variables stand for something, but we can change what we plug into them. So now we're looking at how do we evaluate those, how do we plug those things in. So let's say we have the following algebraic expression. Q is equal to 4C plus 3N. Alright, so that is just some random expression. I'm not going to tell you that Q means anything specific, or C means anything specific, or N means anything specific. It's just a random expression. But I am going to tell you that C is equal to 0.7 and N is equal to 1.2. So I've given you this expression, or in this case, an equation, right? It has an equal sign here. So I've given you this equation, and I've given you the value of C and the value of N. So all we need to do is plug these values, or substitute these values in place of the variables. So Q is equal to 4 times C. C is 0.7, plus 3 times N. N is 1.2. So now we can go through and we can multiply and add. We can perform. So obviously multiplication comes first and then addition. So we have 4 times 0.7 is 2.8 plus 3 times 1.2 is 3.6. And now we can add 2.8 plus 3.6 is 6.4. That's evaluating an expression. We have values for the variables, we plug them in and we get an answer. We could do the same thing again, and I could modify this and say, okay, well now C is equal to 2.1 and N is equal to 1.5. If that's the case, that means we're going to plug in different values here, right? So C is equal to 2.1, N is equal to 1.5. Oops. Actually, make that a 5 as opposed to 1, right? 1.5. 4 times 2.1 is 8.4. 3 times 1.5 is 4.5. 8.4 plus 4.5 is 12.9. And that's it, plugging the values into an algebraic expression. Now, as you saw, we were able to plug in a couple values, get a result. Plug in a couple of values, get a result. Well, many times you use these algebraic expressions or equations or formulas to do something over and over and over again. In the past, you've had a word problem and you just took the values and created an equation from it and found the result. Well, if you have that same word problem, but the numbers keep changing, every time with that method, you have to rebuild the equation. You have to take those numbers, build an equation, find the result. Take those numbers, build an equation, find the result. Whereas with something like this, with a formula, you can be given different sets of numbers and you just plug them into the same equation that's already set up there and get the result. When you're doing things like that, many times it's helpful to build a table. A table is just we'll say a list of multiple columns of information. Do not confuse tables with charts. Many students confuse tables and charts and graphs. Tables are basically lists of numbers combined together. Charts and graphs are pictorial drawings, okay, to represent things. So let's say we have the following equation. N is equal to 34.3 plus 3.2x. Okay? And what this represents is the noise level in dBs in a classroom depends on the number of students x, so N is the noise level in dB, dB is decibels, okay? So the noise level in dBs and decibels depends on the number of students, x, and the resulting noise level, based on the number of students in the classroom, can be found by taking this formula, 34.3 plus 3.2x, which is essentially saying for every, or I should say, the base noise level is 34.3 dB, and then for every student that becomes part of that classroom, it raises the noise level by 3.2 dB. So that's what this formula is telling us. So now I want to find or fill in this table with the resulting noise levels. So I'm going to do this. So x, the number of students in the classroom, 3, 7, 12, 20, and 32. Okay, and then we want to find the noise level N with each of those. So what we're going to do is we're just going to take the input here, the x value, the number of students, and plug it in here and find out our resulting output, the noise level associated. So grab myself a calculator. Feel free to grab yourself a calculator. So what we're going to do is order of operations says multiply and then add. So we're going to take 3.2 and we're going to multiply that by 3, our first value for x, which gives us 9.6. And then we're going to add that to 34.3, which gives me 43.9. So 43.9. I can now do it again, 3.2 times 7 gives me 22.4 plus 34.3 gives me 56.7. If we have 12, 3.2 times 12 gives me 38.4 plus 34.3 gives me 72.7. If we have 20 students, 3.2 times 20 gives me 64 plus 34.3 gives me 98.3. And then if we have 32, 3.2 times 32, 102.4 plus 34.3 gives me 136.7. And we've just created a table. We were able to run through a number of inputs, the number of students having 3, 7, 12, 20, and 32 students, and calculate the noise level in the classroom with that many students as 43.9, 56.7, 72.7, 98.3, and 136.7. And I will point out to you that there was a study done about noise levels in classrooms, and they did checking a number of classrooms, a large number of classrooms, and they found that the average noise level in a classroom was about 72 dB. So about sitting here where we've calculated for 12 students. And for students to be able to concentrate and focus on the work that they're supposed to be doing, that noise level needs to be a lot lower. It should really be much closer to this 34. It should be about 35 dB to get down. So they're finding that classrooms quite often are too noisy. They're talking about external noise, things such as the heating system, traffic outside, and other things, creating all this noise in the classroom and showing that it affects people's ability to do the work and to be able to focus and learn. Okay, so one last thing I want to do with this is dealing with evaluating expressions when you have negative numbers for your inputs. So let's just grab another basic equation. Let's say A is equal to 7B minus 2C. So A is equal to 7B minus 2C. And if we have B equal to negative 1.8 and C equal to 6.1. Okay, so now it's the same thing. We're just going to plug these values in or substitute them for the variables up there. But now we have to deal with negative numbers. So we just want to make sure that we keep that in mind. So A is equal to 7 times negative 1.8 minus 2 times 6.1. So we just plugged in negative 1.8 for B and 6.1 for C. So when we multiply that, just grab my calculator again. When you multiply numbers with opposite signs, the sign will be negative. So negative, and 7 times 1.8 gives me 12.6. So we have 12.6, and then we're going to subtract these numbers. 2 times 6.1 is 12.2. So minus 12.2. When we subtract, now remember when we're dealing with subtracting sign numbers, it can be easier if we change it to addition. So that's equal to negative 12.6 plus negative 12.2. Remember, keep, change, change. So we kept the negative sign here, we changed subtraction to addition, we changed that positive number to a negative number. And now when you're adding sign numbers, if the signs are the same, then add the numbers up and keep the sign. So we get negative 24.8. Most common mistake for people to do is they end up subtracting the 12.2 from the 12.6 and they tell you that it's negative 0.4. And that would be wrong. So just be careful. I know that we're beyond these things, but we still have to remember those basics that we learned in times past so that we can not make simple errors when we're trying to work on things that are a little more advanced.